Hey folks, good evening and thank you for joining on a Sunday evening. So let me just check if everything is working well. If it is, we can get started. So let me just check. Just give me a second. If it is, we can get started. So let me just check. Yeah, everything seems to be good. So no problems. Sounds good. So no major issues that I see. So yeah, let's wait for a couple of minutes for everyone to join in. Ayush, Ayush, my suggestion for you is, because you had exams and you missed a few subjects, my suggestion for you is to follow the schedule from now onwards. Whatever subjects you could not cover, let's cover them later, right? Because we'll anyway revisit these subjects over and over again for the other batches. So that's perfectly okay. Okay. So since you have missed this subject, since you have missed some of the subjects because of your exams, that's perfectly okay. Let's continue from now onwards and just follow us from now onwards diligently. We'll come back to these topics that we have missed, right? So yeah, this is important. Somebody's asking about scholarship test. So based on feedback that we got from a bunch of students, so we are doing this scholarship test and all the students were already registered. I also mentioned this in the video that we made, right? So all the students who have already registered for the course by paying a fee, suppose let's assume you get in ranks 1 to 100, you get a full refund, right? Just like anybody else, right? And if you get let's say from rank 101 to 200, where we have a 50% fee concession, you'll get 50% refund, right? So no problem. Yes. So where are we? Okay. So again, the scholarship test is not about any students per se. It's general, right? And we wanted to keep it general. That's why we are not doing whole of data structures and algorithms also for the scholarship test. Whatever is needed for the scholarship test, like for example, we have 15 days or so, right? 15 to 20 days for the scholarship test. If you're interested to take the scholarship test, all the contents for the scholarship test and practice tests are freely available. Please go through them and prepare them, right? So that's what it would be. Yeah, somebody's asking which subject shall we start next. So today, since we're finishing calculus, from tomorrow we'll start the other major part of discrete mathematics called as we'll discuss algebraic structures like sets, relations, functions, lattices, monoids, groups, all that part. We are planning, again, we'll put it out tonight positively, and we are hoping that we'll put out the schedule. We are planning to finish that in 6 days max. So starting tomorrow, from Monday to Saturday, right? We should comfortably be able to finish all of these algebraic structures like sets, groups, monoids, lattices, functions, relations, all of these topics, right? In discrete mathematics. So that will be the topic. So somebody is asking, why not core subjects? What makes you think that discrete mathematics is not a core subject of computer science? It's one of the most scoring subjects, by the way. So please don't think that only databases and operating systems are core subjects. Discrete mathematics is a core subject for computer science. It's super duper important. And that's why we're doing it now. Again, mathematics in general is a very, very scoring subject. I think we'll easily get about 15 marks from mathematics. That's why we're focusing on mathematics right now. Again, discrete mathematics is a core subject. Please don't misunderstand that. Because if you look at it, discrete mathematics is not there for other branches of engineering. For example, electrical engineers, electronics engineers, they don't have all the topics that we have in discrete mathematics. So it's a very computer science specific core subject. So that's why we are covering it now, right? Okay, sounds good. Okay. So there is some problem with the test. Okay, the team, I'll forward this to the team and they'll look into it. Sorry for the trouble. Okay, since we have 20 problems, let's go into them. And again, there is one very important thing that I wanted to mention, which is that typically calculus for computer science students in GATE is very easy, relatively speaking. As compared to what? As compared to calculus for, let's say, for ECE or electrical engineering students or mechanical engineering students or civil engineering students. The calculus in GATE CSE is actually very simple. And what we have is single variable calculus, very simple calculus. If you recall, if you have seen the videos, most of these concepts are revision of what we learned in 11th and 12th class. Actually, to be honest with you, the IIT JEE, right? IIT JEE mains or IIT JEE advanced as it is called now. That paper, calculus, is harder than GATE CSC paper, to be honest with you. Okay, so GATE CSC calculus is easier than IIT JEE advanced calculus, to be honest with you. Okay, so, and of course you get typically 2 to 3 marks from calculus. Again, depends, right? So how many hours of content is there in those free videos for scholarship test? I'll have to count it. I don't know it at the top of my head, but I'll ask one of my teammates to respond to that. Naveen, if you're listening to this, can you please respond? How many hours of content is there between linear algebra and data structures algorithms? Can you just tell the number of hours roughly? I don't remember at the top of my head. So if my team anyway, who's responding with the applied course thing, they'll look into it, right? So let's get going. Again, I have not solved all the problems in calculus because I was doing another live session in the morning, a 2-hour live session for AA course. So let's see. Some of these problems I'm seeing first time. So I might be a little shaky when I solve some of these problems because I have not come thoroughly prepared like others. I have not solved these problems prior. So I might get a little shaky, but I'll try to do my best. Okay, sounds good. So let me just share the screen because we're short on time. Okay, so any questions? By the way, folks, any questions you have about the scholarship test or anything, please reach out to us over email or just call us, right? So if you're a registered student or otherwise, just give us a call and we'll help you and we'll try to answer as many questions as you have, right? Sounds good. So let me share the screen now. Let's share this. Okay, so let's get into the calculus questions. Again, some of the questions that we have for calculus are harder than gate level, and that's intentional, like every other time, right? Some of these questions are at gate level, some of them are slightly above gate level. Let's look at this limit. Okay, so this is as x tends to 2. So if I replace 2 here, what happens? This is 8. This is minus 4 into 4, which is 16, plus 4 into 2, 8. This is 4 minus 4. So this is in the 0 by 0 form, which means I can use the L'Hopital's rule, right? So which means I can use the L'Hopital's rule or L'Hopital's rule, okay, which we have discussed in the course videos. Some people also call it as L'Hospital's rule, but the appropriate French pronunciation of this is L'Hopital, right? So since it is in 0 by 0 form, I can differentiate numerator and denominator. So this is equal to limit x tends to 2. Limit x tends to 2. X cube derivative is 3x square. X square derivative is 2x. So minus 8x plus 4 by derivative of this is 2x. Right? Now let's see what happens. Right? When I have this, if I replace 2, now what happens? So this limit is equal to this limit from L'Hopital's rule, right? So if I now just use 2, so 3 into 4, which is 12, right? So this is 12. So this is 12, right? Minus 8 into 2, 16, plus 4. So the numerator equals to 0. What about the denominator? As x tends to 2, if I replace 2 here, this will be 4, right? And this is in 0 by something, which means this value is equal to 0. So limit of this, if I just apply L'Hopital's rule once, I get that this limit is equal to 0. That's it. Very simple problem, right? And these are the types of problems that you have seen in GATE. By the way, all the solved problems that I've discussed in the course videos at the end of every unit are mostly GATE questions, as you might already know, right? So first question done. So let's go to the second question now. So what does it say? Okay, so let's look into the second question now. So it says I have integral of, so I hope I've shared the screen just to be sure here. Just give me a second. Yeah, the screen is shared, no issues. Okay, let me also just see. Okay, sounds good. Okay. Okay, so let's solve the next question here. It says if integral of this is 7, what is the integral of this? Okay, so let's try to solve this now, right? So what do we have now? We have integral of 2 to 5 f of x, right, minus 3 dx, right? This is what we have, right? This is equal to 7. This is what is given. Now I can write this as integral 2 to 5, right? I can write this as integral 2 to 5 f of x minus integral 2 to 5 3 into dx. Again, there has to be dx here, right? This is from one of the basic rules that we discussed for definite integrals, right? We discussed this rule. Now what is this equivalent to? This is equivalent to integral of 2 to 5 f of x, right? F of x dx minus, what is this integral? Right? This will be 3 into x, right? Look at this. What is the integral of this? If I solve this, what will I get? I'll get 3x between 5 and 2. So this will be equal to 9, right? So this part is equal to 9. And now what are we given? We are given that this integral is equal to 7. So which means this is equal to 7, which means integral, which means this integral of 2 to 5 f of x dx equals to 16, right? So we have this. So now what does it say? It says, I want to compute this, right? So what is this equivalent to? That's the question here, right? So we have this fact, right? So let's just remember this fact. I'll clear this screen and we'll solve the problem in the next screen. Now, given this, now let's try to break this up, right? So what do I have here? I have 0 to 3, 2x dx, right? So I can write this as 0 to 3, 2x dx, right? Minus 0 to 3, f of x plus 2 dx, right? I can write this as this, right? Breaking it into two parts. Now, look at this. What is 2x dx? What is the integral of x, right? If you actually look at this, right? So what do I have here? So I can easily simplify this, the integral of 2x, right? So now this part is easy, right? Now the tricky part here, again, this part is easy. Now what about this part? Okay, so I can write this as 0 to 3, 2x dx minus, what about this part? Now if you see this part, if x is going from 0 to 3, right? What will x plus 2 go from? Look at this. I can change this variable. Instead of x plus 2, suppose if I write x plus 2 equals to u, then what happens here? This becomes u, this becomes du, and what about u? The u itself will go from 2 to 5. If x is going from 0 to 3, x plus 2 will go from 2 to 5, right? Right? This is what we have. Now, instead of u, I can change this variable and write x also, right? I can just change this variable back and call it dx also, right? Now, if we solve this, now remember, we already got an equation for this. We already solved this earlier, right? In this previous screen, if you notice, we already got an equation for that this is equal to 16. So now this is 16. Now, if I simplify this, again, this is a simple integral, simple definite integral, I'll get 9. So 9 minus 16, I'll get minus 7. So the answer here is minus 7, right? So this is slightly more involved question. This is slightly on the harder side as far as GATE CSC is concerned, right? So this is slightly on the harder side of GATE CSC is concerned, right? If you look at all the past questions, this is slightly on the harder side for sure, but it is very much solvable. If you know the basic properties of definite integrals that we've discussed in the course videos, this is simple algebraic transformations, right? It's not a rocket science, right? So let's look at the next question now. Okay, so it says if a and b are prime numbers. Okay, so this question is slightly tricky. Let's see. If a and b are prime numbers and I have x square minus ax plus b equals to 0, if they have two different positive integer roots, there are two roots to it, then what is a plus 2b? Okay, so let's see. I have two. Let's assume I have two roots, x1 and x2. What does roots mean? If I replace, if I place x1 here, I'll get a value of 0. Similarly, if I place x2 here, I'll get a value of 0. That's what roots means, right? So if you have a quadratic equation, again, this question is not specific to calculus, but it's good to think about it in this form, right? So actually, if x1 and x2 are roots of it, then I can write this whole thing as x1 minus x2 into x minus x1 into x minus x2. I should be able to write this as minus ax plus b, right? Again, this is sort of something like this is something that we have seen in integration when we learned about integration by partial fractions, sort of, not exactly this. Now, if you notice, if x1 and x2 are numbers, right? We don't know what x1 and x2 are. Again, this is a is a root. Sorry, no, a is not a root. Sorry, x1 and x2 are roots. I'm sorry, x1 and x2 are roots. So what will b be? Look at this. Here, if you look at x square term, you will have an x square term here. The x term will have minus x multiplied by x. Sorry, minus x1 multiplied by x minus x2 multiplied by x. What about the b term? This b term will be equal to x1 into x2. Right? Look at this. This b term will be equal to x1 and x2. And we are told that a and b are primes. Look at this. We are told that a and b are primes. Right? If x1 into x2. So what do we have? We have x1 into x2 equals to b. And b is a prime number. If b is a prime number, then one of them has to be equal to 1. Let's assume this is equal to 1. The other will be equal to b because b is a prime number as given here, right? So let's assume x1 equals to 1, x2 equals to b. Okay. Now this is good. Now what about this a? Look at this. What do I have here? If you notice, if I compare the coefficient of x term here, I'll get minus x1 into x. Look at this, right? Minus x2 into x. This is, so I'll have minus of x1 plus x2 into x. I'll have a coefficient of minus of x1 into x2 for x. And what is the coefficient here? Minus a, which means x1 plus x2 should be equal to a. Look at this, x1 plus x2 should be equal to a, right? Which means x1 and x2 are 1 and b, which means 1 plus b should be equal to a. And look at this, it says a and b are prime numbers. What two prime numbers only have a difference of 1 between them, right? If a equals to 3 and b equals to 2, these are the two prime numbers. Again, 2 and 3 are prime numbers, which are off by only one number, right? So using the property that a and b are prime number, and using, see, what am I doing here? I'm simply comparing the coefficients. Okay, if x1 and x2 are numbers, this is the coefficient of x power 0. I'm comparing the coefficients of x power 0 and x power 1, and I've solved that a equals to 3 and b equals to 2. So if a equals to 3 and b equals to 2, 2b equals to 4, this whole thing will be equal to 7, right? Again, this is very simple. Okay, this is very simple. What have I done? Again, if I were not given the fact that a and b are prime numbers, I wouldn't have been able to solve this. It's a very, very critical fact here, right? So this is cool. Okay, again, very simple problem here. Again, this problem is inspired slightly from the integration. Again, comparing the coefficients of the terms, right? Again, simple algebra, nothing very fancy there. Okay, this is actually a good question. Okay, so what this question says is, find the minimum value of f for this expression, right? Find the minimum value for this expression. Look at this. This expression has 4 terms. So this expression will contain x power 4, right? Some x power 4 plus x power 3 plus x square, right? Plus some x plus this. So this will be a polynomial in degree 4. If I differentiate this, what happens? If I differentiate this, right, I will get a polynomial. I'll get a polynomial in degree 3, right? I'll get a polynomial in degree 3. Now solving a polynomial in degree 2 is easy, right? See, for example, if I get a polynomial in degree 3, if I equate it to 0, solving it is very cumbersome. And again, multiplying these numbers will make it one hell of a question, right? So instead of doing that, can we somehow simplify this? Let's try to simplify this now. So if you try to solve this problem, using derivative of x, the first derivative and the second derivative strategy, this will take a lot of time in an examination setting, right? So there's a very nice trick for problems like these, right? So the trick is this, okay? It's actually a very nice trick. So you say x equals to u plus, what is the middle number here? What is the middle number between these 4 numbers? 2017.5. Okay, if you write x equals to this, right? If you write x equals to u plus this, then what can I write this whole expression as? I can, look at this. I can write this expression, I can write x minus 2016 as u plus 3 by 2. Look at this. I can write this as u plus 3 by 2, right? Right. So what is u now? What is u? U is nothing but x minus 2017.5. So I can write this term as u into 3 plus 2. I can write this term as u plus half. Right. Look at this. This is my u, right? I can write this. I can write this as u minus half, and I can write this as u plus 3 by 2. Look at this. This is what makes the problem fun, right? So if you notice, sorry, not plus, it has to be minus here. Sorry. This is u minus 3 by 2. And now this format is very useful because now I can multiply these two and simplify it. Look at this. If I multiply these two, this is like a plus b into a minus b. What do I get? I get u square minus 9 by 4, right? If I multiply these two, right, I can get u square minus 1 by 4, right? This is actually cool, right? Now, if you look at this problem, if I simplify this whole thing, right? If I simplify this whole thing, I can write this as, okay, so I have u square, right? So I can, if I simplify this, I can write it as u power 4 minus 5 by 2 u square, right? 5 by 2, this and this, yes, plus 9 by 16. I can write it like this, right? Which I can again simplify it. Again, I want to find the minimum value, right? I want to find the minimum value. This is still a function. Again, this is also a 4th order polynomial, right? So there's a very nice strategy that we'll employ here. Again, problems like this are very, very common at IIT JEE level, right? These are very, very interesting problems. And these are actually very good problems, right? So how do I simplify this now? I can write this whole thing as u square minus 5 by 4 whole squared, right? Minus 1. Okay, now you might wonder, why am I writing it in this form? Now, if you look at this, this is a square of a number. Square of any number is greater than equal to 0. Look at this. For any value here, the square of any number is greater than equal to 0, which means this whole expression will be greater than equal to -1 because I have a -1 here. If this whole expression is greater than equal to -1, what does that mean? What does it say about the minimum value of this expression? The minimum value of this expression is -1, right? Again, this problem is not straightforward. This is one of the harder problems. Okay, and it's fairly hard to come up with this strategy on your own if you have not seen problems like this, right? It is by intentionally that we gave some of these slightly harder problems to expose you to. Again, if you might have solved some of these problems in your 12th class, by the way. And to solve problems like this, all you need is 12th class mathematics, right? And most of the calculus syllabus for computer science for GATE is actually 12th class syllabus. There is not much of some advanced concepts here, right? Again, the trick here is to convert this into this form, then get a fourth power, and then simplify it this way. Again, this is not straightforward. It's not easy to come up with this out of the blue. It requires a lot of practice to solve some of these harder problems. But we wanted to expose you to some of the really hard problems in calculus also, because you never know who will set the paper for you, right? So let's look at this question now, right? This question says, I have f of x equals to this when x is not equal to 2. I have this when x equals to 2. And it says this function is continuous at x equals to 2. What is the value of k? Right? So for it to be continuous, what should we do? We should have the limit of this function f of x, right, at 2 minus, and the limit of this function at 2 plus, right? Sorry, as x tends to 2 minus and as x tends to 2 plus should be equal to f of 2, right? Only then it is continuous, right? So let's actually compute the limit of this as we tend to 2, right? As we tend towards 2. That's all you have to do. If you solve that problem, you're done, right? So what we have to solve for is limit x tends to 2, right? We have to solve the limit for x cubed plus x squared minus 16x plus 20 by x minus 2 whole squared. This is the limit that we have to solve. Now, one thing, look at this. The whole thing is becoming slightly cumbersome. Again, there are multiple ways of solving it. One interesting way to solve this is, look at this term. When x equals to 2, this is becoming 0. So if I can somehow write the numerator in terms of x minus 2 whole square, I can cancel these two things out. That's the strategy here, right? So let me try to represent, see, this is a cubic term, right? This is a quadratic term here. So can I write this numerator somehow? Can I write this numerator as this x minus 2 whole square by x minus 2 whole square, right? So that I can cancel out x minus 2 whole square with something else. What would this be? So if you try to find what this will be x plus 5. Remember, this is a cubic term, right? So cubic term is a product of order 1 term and order 2 term, right? Now everything becomes simple. So this is equal to limit x tends to 2, this thing, right? Now I can cancel this and this. So this will become equal to 7, right? Of course, this is not the only way to solve it. I'm assuming that can we apply L'Hopital's rule here? Again, I'll have to test it, but this is one way that I solved this question myself. Because I have this denominator term, which is quadratic, and I have a cubic term here. I'm trying to represent this cubic term so that I can cancel this out. That's a strategy that I tried to employ. Now, as limit x tends to 2, this value equals to 7. So what should k be? What should k be? K should be equal to 7. Only then will f of 2 be equal to the limit x tends to 2 f of x. And that's the requirement for the function to be continuous, right? So k equals to 7 here, right? So I hope you got a sense of this problem. This problem is, again, very much at gate level. This is very doable, right? So now let's look at a slightly more interesting question. Actually, this question was slightly challenging. So when I was trying to solve it, it took me a while to solve it. This is actually a very good question. So it says, let's assume I have a function which is continuous, which let f be continuous decreasing function. It says it's a decreasing function with this requirement. Then what is this? Okay, so we are told that this is a decreasing function, right? So it took me a while to figure this out. Again, this is not trivial, right? So if it's a decreasing function, what happens? Look at this. It's a decreasing function, and the domain of these numbers is 1 to infinity, which means all of these numbers are positive numbers, right? Your 4x, 8x, 6x are positive numbers. Now, because it is decreasing, f of 8x is going to be less than equal to f of 6x is less than equal to f of 4x. Remember, it's a decreasing function, right? Which means since it's a decreasing function, remember 4x, remember that 8x is greater than 6x, greater than equal to, which is greater than equal to 4x, right? And as we are increasing, because it's a continuous and decreasing function, these values should be like this, right? This is a very, again, this was the tricky part that took me some time to figure out. Once I figured this out, this problem was straightforward, right? So once we figure this out, let's divide everything by f of 8x, right? So I can divide this whole thing by f of 8x, right? I can divide this whole thing by f of 8x. Now, once I've divided everything, I can take limits here now. Let's take limit x tends to infinity here. Similarly, limit x tends to infinity here, limit x tends to infinity here. As limit x tends to infinity, f of 8x by f of 8x equals to 1, right? Now, what do we have to find? We have to find this. So what is this? What is the second term? Limit x tends to infinity, f of 6x by f of 8x. This is something that we have to find, right? What will this be? What will this be less than equal to this? But we are already given that this is equal to 1. We are already given that this is equal to 1. If there is a term which is greater than equal to 1 and less than equal to 1, what would this be equal to? This has to be equal to 1, right? Right? So this is actually equal to 1. And again, this problem is slightly on the harder side. If this idea doesn't strike, sorry, if this idea does not strike, it is fairly hard to try solve this problem. And to be honest, it took me some time to figure out this concept myself. Okay, this is certainly on the one of the slightly harder problems, especially if you cannot come up with this idea, it will be tricky, right? So, okay, so let's look at another question here. So what does this question say? This question says, consider a function fx satisfying this equation, very good, for all real values, okay? If fx is differentiable for all x and f dash of 4 equals to 40, what is the value of this? This is slightly tricky, but it is doable, okay? So what are we given here? We are given that fx equal to f of 4x minus 2. And we are told that this function is differentiable, which means the derivative of this should be equal to the derivative of this, right? Now, what is the derivative of this function? The derivative of this function is 4. Again, I'm just applying simple chain rule, right? It will be 4 into f dash of 4x minus 2. So f dash of x, right? What does this imply? This implies this. Now, what are we given? We are given that f dash of 4 equals to 40. So if I place 4 here, okay, if I take f dash of 4, I'm told that this is equal to 40, which is equal to 4 into f dash of, if x is 4, what happens? 4 4s are 16, 16 minus 2 is 14, right? So what does this mean? This means f dash of 14 is equal to 10. Very good. But what do we want? We want f dash of 54. Right? We want f dash of 54. Now, how do we come up with f dash of 54? Let's actually try to do this. Again, let's reuse this equation again. Let's try to reuse this equation. So what do I have now? I have f dash of, let's assume what is f dash of 14 equals to 10. And if I use this formula that f dash of x equals to f dash of 4 into x minus 2, right? What is 4 into x? It is nothing but 4 into 14 minus 2, right? Now, what is this equal to? F dash of 54, right? Sorry, 4 times. So this is equal to 4 times this, I'm sorry, right? So this is equal to 4 times this. So 4 times of this is equal to 10. So what is now f dash of 54? F dash of 54 is equal to 10 by 4, which is 2.5. So the answer here is 2.5. Again, this is very much, again, this is not a rocket science problem. This is very doable problem. All it requires you to work out is to apply the chain rule here and solve a bunch of simple equations. Right? So this is tricky, but not very hard. If you put your mind to it, you can easily solve this problem, right? So now let's go to, again, I'm going a little fast because we have more questions today. That's why I wanted to solve it, right? So now let's see this. Okay, I've not solved this, so I might get stuck here. Let's see. So I have this limit. Okay, so let's say this is equal to this, and it says what is the limit of this? So, okay, let's try to solve this problem, right? So let's assume L equals to this, okay? Because I have this exponent term here, right? I have this square nth root. That's why I'm taking this so that I can exponent it, right? So I can now write this whole thing as limit n tends to infinity, right? Limit n tends to infinity, exponent of, look at this. I can take exp of log. If I take exp of log, it will be the value itself, right? I can take exp of log of, right, nth root of This is nth root, right? Nth root of pi power n plus e power n. Now this is perfectly all right, right? Because exp and log will cancel each other, and exp and log will help us get rid of this nth root. It will make it simple for us, right? So this I can write it as, again, this limit I can take it inside. So this is equal to exp of, or e power. Exp basically means e power. So e power x is often written as exp of x, right? So just wanted to make that clear. I can write this as limit n tends to infinity log of, right? Log of nth root of x, sorry, pi power n, nth root of, sorry, nth root of pi power n plus e power n, right? That's what I have, right? Okay. So let's see how we can solve this, right? Now, if you notice, so again, let me try to represent this slightly differently, right? So log of this, what is log of this? So this nth root can be written as, this nth root can be written as power 1 by n, right? So I can write this as exp of limit n tends to infinity, limit n tends to infinity. So I can take 1 by n outside right now, right? So what I'll write this as limit n tends to infinity log of, right? So I'll try to write this as log of pi power n plus e power n by n, right? So this is what I have now. Now, if you notice, as n tends to infinity, what happens? This becomes infinity, right? This will also become infinity. So this is an infinity by infinity form, because log of e power n, look at this, log of e power n will become, because log and e are inverses of each other, right? So the numerator is infinity, the denominator is infinity. So this is an infinity by infinity form, which means I can apply L'Hopital's rule now, right? So I'll write this as exponent of limit n tends to infinity. Again, this is slightly tricky, but if you're patient with it, you can solve it, right? So let's try to solve this. The derivative of the numerator by derivative of the denominator. So what is the derivative of the, so let's actually work this out, right? So the derivative of the denominator is 1. That is simple. So I can just ignore this. Let's just ignore the denominator. What about the numerator? What is the derivative of the numerator? I'll get pi power n log of pi power n, right? Plus e power n by pi power n plus e power n, right? So if I differentiate both sides, if I differentiate both numerator and denominator, this is the term that I'll get. Now in this, if you notice, pi power n is here and here. So I can divide both numerator and denominator by pi power n, right? So if I divide both numerator and denominator by pi power n, I'll get e by pi power n here, and I'll get e by pi power n here, right? So what do I have? I can just ignore this pi power n here. I can ignore this pi power n here, right? So this will become 1, right? And this is as is. Now if you notice, as n tends to infinity, what happens? Now let's see what happens as n tends to infinity, right? As n tends to infinity, so this will become log of pi power n, right? So this will become n into log pi, right? Look at this. So it will become, 1 second. So did I get this right? 1 second. So this is pi power n. So did I write this? So the pi power n will cancel out. So I'll have 1 second. So let me just go back here. I think I've done a mistake here. Okay, let me write this properly, right? So what is the derivative of this? The derivative of the denominator is 1. So we can ignore this, right? If I compute the derivative of the numerator, what will I get? I'll get limit n tends to infinity pi power n log pi, not log pi power n, sorry, plus e power n by pi power n plus e power n. This is what I'll get. Yes. So if I now remove pi, if I divide everything by pi power n, this pi power n will be deleted. This pi power n will be deleted. And here I'll get 1. Here I'll get e by pi power n. I'll get e by pi power n. Okay, this makes sense. Now this makes sense, right? Now look at this. E by pi. E is less than pi. Look at this. E is less than pi. E is 2.7 something. Pi is 3.14. So E by pi is less than 1. Is a value less than 1, but it is greater than 0. So anything that is a decimal value, anything which is like 0.5 or 0.6, if I raise it to infinity, if I multiply it infinite times, this will become 0. Right? This will become 0, right? Similarly, this will also become 0. So what am I left with? I'm just left with exp of log pi. So exp of log pi is pi itself. So the answer here is pi. Again, I've not solved this question earlier. That's why I've made some mistakes here. But this is very much solvable, right? See, all the trick that I've done here is because again, the reason I've done this is because I have the nth root. I want to process this nth root. I knew that I had to use log and exp or some variations of log and exp. Even if I did not use this exp, imagine I did not use this exp, let's say, right? I just took log of this term. Again, if I did not use this exp, everything would have worked out. What would I have got is log of pi. If this is L, right, then log of L is log of pi. Right? That's what I would have gotten, and I could have solved it. Again, similar trick we have seen in some of the solved problems in the course videos also. Of course, this is slightly tricky that you're using the log and then you're also using the L'Hopital's rule. But this is very much doable. Okay, again, this is the first time I'm doing this problem myself. It took me a little while, but it's doable. Okay, so let's go to the next question now. Okay, so what is this next question? Limit extends to 1, x by x minus 1 minus 1 by log x. Okay, so if x tends to 1, what happens? This is 1 by 0 minus. So actually, let's simplify this equation, right? Let's actually simplify this equation. Limit x tends to 1, right? X by x minus 1. So the denominator will be x minus 1 into log of x. What will the numerator be? The numerator will be x into log of x minus x plus 1, right? So this is what it will be, right? As limit x tends to 1, right? This is what it would be. Now, if x equals to 1, this becomes 0. If x equals to 1, this becomes 0. And so this is in 0 by 0 form, which means I can simply apply L'Hopital's rule now, right? So let's differentiate the numerator and the denominator. So if I differentiate numerator and denominator, I'll get log x in the numerator, right? And I'll get log x plus x minus 1 by x in the denominator, right? Again, I'm making some simplification just in the interest of time. Again, simple L'Hopital's rule, right? Differentiate the numerator, differentiate the denominator, and this is what you would get, right? After some simplification, right? So this I can write it as, now let's try to simplify this, right? So this I can write it as, so now what happens if I place x equals to 1, the numerator becomes 0, right? The numerator becomes 0, but here I have 1, here this becomes 0, and this becomes 0. So again, let's try to simplify this. I can again apply L'Hopital's rule, but let's try to simplify this a little. I think there is a way to simplify this, right? So if I divide both numerator and denominator by log x, what do I get? I get 1 plus 1 by 1 plus x minus x into log of x, right? Again, this expression is slightly complicated, but let's focus on this. See, if I can solve what this expression is as x tends to 1, I've solved the problem, right? See, if I know what this value is, I've solved this problem. So let's solve that sub-problem. Limit x tends to 1. What is x minus 1 by x log x? Again, this is in the 0 by 0 form, right? So let's try to solve this problem by taking derivatives, right? This is equal to limit x tends to 1. If I take the derivative of numerator and denominator, I'll get 1 by 1 plus log x, right? So this is what I'll get, right? So yeah, if I apply L'Hopital's rule on x minus 1 by x into log x, this is what I'll get, right? And as x tends to 1, what happens? This becomes 0, so this will become 1 by 1, so this is equal to 1. So as x tends to 1, this whole thing will become equal to 1, which means this whole ratio will become equal to 1 by 2, right? So 1 by 2 is the answer, but is the answer there? Oh, it's not here. So answer is none of the above. The answer actually is half. Okay, I actually didn't even look at the answers sometimes. Again, for some of these limits problems, you can always take, again, you remember the tabular method that we discussed in the course videos? If you have a calculator and if you're fast with that calculator that is there in the examination setting, you can just replace x equals to a very small value like 0.999, very close to 1. Similarly, just place this and see what it is coming close to, right? Simpler tabular method. Again, that's also super duper useful. If you're not comfortable with solving these problems using L'Hopital's rules, etc., this shortcut, while it is time taking, especially if you're good with the calculator that is available in the examination, this can help you solve problems very, very quickly, right? So now let's go to the 10th question. Okay, so let's see. Find the value of k for which the following limit exists. Okay, so let's see. This limit exists, right? That's the question. So if this is my x, okay, so if this is my, so let's call this f of x, right? If this is my f of x, now actually let's take the denominator. Let's play with the denominator first. Okay, how can I decompose this denominator? Okay, this this, okay, I have k here. Okay, so let's try to decompose this denominator first. So this is a quadratic term, so I should be able to write it into two terms, right? So I can write this as x minus 3 into, I can write this as x minus, again, I can compute the roots of this and I can write it as x minus 3 into 2x plus 1, right? I can write the denominator like this, right? Now, what do I have for the numerator? Let's keep the numerator as is. 4x square plus kx plus 7k minus 6. Now, as x tends to 3, look at this, as x tends to 3, this becomes 0. Right? So if I can have something in the numerator which will cancel out this x tends to 3. See, in the numerator, if I can have it in the form of x minus 3 into something, right? Because this is also a quadratic term, right? In the numerator, if I can have x minus 3 multiplied by something, the new denominator is x minus 3 into 2x plus 1 anyway, right? So if these two will cancel out and I can work out the whole thing, right? Now, again, I don't know what k here is, okay? So to make this whole thing work, what is the feasible value of k? Right? Only then, see, I need to have x minus 3 in the numerator, right? What if my k here is, okay, I don't know what k here is. This kx minus plus 7x, right? So imagine if I have, so let's try to solve this, right? I want this to become equal to 0, okay? So if x minus 3 is a root of this, okay, there's a better way to think about it. If x minus 3 is a root of this, if I place 3 here, this should become equal to 0. So 4x square plus kx plus 7k, plus 7k, or yes, plus 7k minus 6 at x equals to 3. At x equals to 3, this should be equal to 0 if 3 is a root of this, right? Sorry, if x minus 3 is a root of this, right? So if I just replace 3 here, what would I get? I would get 30 plus 10k equals to 0. So I'll get k equals to minus 3. Right? I hope, see, for me to have x minus 3 as a root of this expression, this is a quadratic expression, right? If x minus 3 is a root of it, if I replace x with 3, this whole thing should be divisible by it, right? And that's a very simple property of quadratic functions, right? So this whole thing should be equal to, yeah, that's it. It should be exact. So at x equals to 3, this whole thing should be equal to 0. So I just placed x equal to 3 and simplified this. I got this. So k equals to minus 3. So the answer here is k equals to minus 3. Again, how did we solve this whole thing? Very simply by decomposing the denominator. Again, typically, I know that there is going to be x minus 3 here because the limit is x tends to 3, right? Right? That's why I typically initially write x minus 3. See, when I was solving this problem, I quickly wrote x minus 3. Then I tried to figure out what the rest of the term is. Okay, because that makes sense, right? Otherwise, why would this problem even be given by the person who said this question, right? So I hope you got a good sense of this question. Again, this is very solvable. So let's go to the next question here. So it says Vn be a sequence defined by V1 equals to 1 and Vn plus 1 is this. Okay. What is limit n tends to infinity Vn equal to? Okay, so let's solve this question, right? So, okay, so how do we tackle this question? Let's go step by step. Let's write, so this is what my Vn plus 1 is, right? Sorry. So this is what my Vn plus 1 is. First, let's get rid of the square root because they're hard to process. So Vn plus 1 squared equals to Vn squared plus 1 by 5 power n. Okay, so this makes more sense, right? Now, can I write this as Vn plus 1 squared minus Vn squared, right, is equal to 1 by 5 power n. Now, let's see if n equals to 1. Look at this. This says for n greater than equal to 1. So V2 squared minus V1 squared. What is it equivalent to? It is equal to 1 by 5. Right? Now, what is V3 squared minus V2 squared? It is equal to 1 by 5 square. Right? So on and so forth. Similarly, V4 squared minus V3 squared is equal to 1 by 5 cube. Right? And so on and so forth. Right? This is what I have. Now, what am I being asked? Limit n tends to infinity. What is Vn equal to? Okay. So let's try to solve this problem, right? So what can I do now? So, okay. There is a nice hack here in algebra, right? So if I add up all these terms, look at this. If I add the LHS and RHS of all these terms, what happens? My V2 square would get cancelled out, right? My V3 square would get cancelled out. So what will I have here? I'll have V1 square plus, look at this. I'll have V1 squared plus Vn squared. If I keep summing up it till n, right, everything else in between would get cancelled out. So what will I have here? I'll have v1 squared. Sorry, v1. I'll have minus v1 squared. Sorry, I'll have vn squared. Okay, let me write this down, right? So I have these multiple equations like this. Let's say I have this equation still vn. So vn squared minus vn minus 1 whole squared equals to 1 by 5 power n. So if I sum all of these equations, what do I get? So I get vn squared minus v1 squared is equal to 1 by 5 plus 1 by 5 squared plus 1 by 5 cube plus 1 by 5 power 4, so on up to 1 by 5 power n. This is what I have. And I'm given that v square equals to 1. So I can move this to the other side and I can write this as that this is equal to 1 plus this. Now look at this. This is actually, look at this. This is actually geometric progression, right? I'm multiplying this by 1 by 5. I'm multiplying this by 1 by 5 and so on and so forth. So vn square now, because it's a geometric progression where the multiplicative term is 1 by 5, I can write this whole thing as 1 minus 1 by 5 power n, the whole divided by 1 minus 1 by 5. Right? Again, this is sum of these terms. Right? This is what vn square is going to be. Now, what is this vn square now? If I simplify this, what would I get here? If I say, again, let's take the square root on both sides, because what we want is vn, right? So if I simplify on both sides, if I simplify this and take square root on both sides, I'll get vn equal to under root of 5 by 4 minus 5 by 4 into 1 by 5 power n. Right? Now, limit n tends to infinity. Now, limit n tends to infinity of this. Let's see what happens. Remember, this term is 0.2. 0.2 power infinity will be equal to 0. Right? 0.2, because 0.2 lies between 0 and 1. If I multiply 0.2 with itself infinite number of times, this will become equal to 0. So what am I left with? I'm left with just this term. Again, in this problem, there is a lot of algebraic operations that we have to perform before we even come to the limits part. Okay, that's the tricky part in this problem. Okay, this problem is slightly on the harder side, primarily because of all the algebraic transformations, and especially this trick that you have to sum up all the LHS and RHS here. Once you get that, this problem is straightforward. Right? So let me just take a quick water break and I'll be back. Just give me a second. Just give me a second as we solve them. Okay, let's look at the next question in the meantime. Okay, let me also keep seeing the next question. Okay. So, okay. 10 power n by n factorial. This is a good question, actually. This question is very relevant to computer science students because things like this are stuff that we use in asymptotic analysis, especially for small o and small omega. Again, this is there in our course content in algorithms where we have discussed this. Again, this is interesting. So let's see what I have. 10 power n by n factorial. Let's assume, so as limit n tends to infinity, let's see what happens. As limit n tends to infinity, what is 10 power n? 10 into 10 into 10 into so on, right? Up to n times, right? Up to n times, right? Now, look at this. What is the denominator? 1 into, 2 into, 3 into, so on and so forth. Somewhere it will be 10 by 10. Look at this. I can think of this as 10 by 1. I can think of this as 10 by 2, 10 by 3, so on. Somewhere it will be 10 by 10. And after that, it will be 10 by 11. Look at this. After that, it will be 10 by 11. And then I'll have 10 by 12. Again, I don't even, the very simple limit to compute, right? Then I'll have 10 by 13. If you look at these terms are greater than 1. But all these terms, all the rest of the terms are less than 1. Right? And there are infinitely many terms which are less than 1. If I multiply many terms which are less than 1, this would become equal to 0. Right? So as n tends to infinity, this will be equal to 0. Very simple argument. Again, I know that there are some values here which are greater than 1, which are greater than equal to 1. But there are infinitely many values which are very small. Right? And which are smaller, which are less than 1. And if I multiply all these infinitely many numbers, this product will become equal to 0. Anything multiplied by 0 will be 0. So that's it. Literally one line of argument. Right? So this is a very quick problem. This is actually a very easy problem. It's very relevant to computer science also. Okay, so let's tackle the next question here. And what does it say? I have f of xi multiplied by f of xi plus 1 less than 0. Then, okay, there must be a root of f of x between xi and xi plus 1. Okay. So this is talking about the mean value theorem type stuff. Let's see what it says, right? So what do we have? We have f of xi. Look at this. We have f of xi multiplied by f of xi plus 1, right, is less than 0. Okay. So we have this, right? And I'm assuming that xi is less than xi plus 1. Okay. I'm assuming that. When this product, say, look at this. Imagine if this is my function. Let's assume this is my xi, and let's assume this is my xi plus 1. The product of the value of this function at these 2 points is less than 0, which means, what does that mean? If it is less than 0, what does it imply? It implies that either this is negative or this is negative, right? One of them is negative. So let's assume this value, at this value, the function is negative. Again, both of them cannot be negative. If both of them are negative, it will become positive, right? So one of them is negative and the other is positive. Let's just assume, again, there are many ways of solving this. Let's assume this function is such that at xi, this is negative, but at xi plus 1, it is positive. Look at this. Here it is negative, but at xi plus 1, it is positive, right? Then what does it say? There must be a root of f of x between xi and xi plus 1. What does it mean by to have a root? Root basically means that at some point between xi and xi plus 1, f of x is equal to 0. That's what it means, right? That's what it means. That's what is the meaning of a root, right? When you say roots of a quadratic equation, what do you mean? You mean, where will this quadratic equation become equal to 0? That's what the meaning root is. So given that this multiplied by this is less than 0, what does that imply? That implies that one of them is positive and one of them is negative. It could be the other way also. It could be the other way. But the important thing here is, because this product is negative, the curve can be like this, or the curve could have also been like this, by the way. The curve could have also been like this, where at xi, this is positive, but xi plus 1, it is negative. That's also perfectly valid, right? But whatever is the case, this function has to cross the x-axis somewhere, which means the root must lie between xi and xi plus 1. So A is the right answer. I'm not even looking at the other options here, right? And this comes from simple logic, right? This is very, very simple logic. Nothing very fancy here. Again, the intuition here is very similar to the intuition that we have for mean value theorems, intuitively, right? I'm not proving it rigorously, but intuitively it's the same thing, right? So let's go to the next question. Okay. Yeah, this question was hard. When I tried to solve it, it took me a while to solve this question, to be honest. So the maximum possible value of x into y square into z cube, subjected to the condition that xyz is greater than 0 and x plus y plus z equals to 3. Okay. So this is actually a hard problem. This is it took me a while to solve this problem. Right. So what have we given here? Again, what do we want? We want y square terms and z cube terms. That's the tricky part here. Just given this, see, I don't want x square terms. I don't want x cube terms. I just want terms in x form, y form, and z form. So the trick here is, given this, can I write this as x plus y by 2 plus y by 2, makes sense, plus z by 3 plus z by 3 plus z by 3. Again, why am I writing it 3 times? I'll tell you, I'll come there. Okay, there's a very nice trick here. This is equal to 3. Now, if you think about it, this can be thought of like, we know this formula, right? That arithmetic mean is greater than equal to geometric mean. And in one of the live sessions, I've actually proven this also, right? So arithmetic mean is greater than equal to geometric mean. So if you think of them as 6 numbers, look at them. If I think of them as 6 numbers, what is the arithmetic mean of all of these numbers? The arithmetic mean of all of these numbers is x plus y plus z by 6. That is arithmetic mean. Arithmetic mean is greater than equal to geometric mean. What is the geometric mean of? Geometric mean is x into y square. Look at this, x into y square by 4 and z cube by 27. Again, I broke y into 2 parts and I broke z into 3 parts, primarily because I wanted y square term in the geometric mean and I wanted the z cube term in the geometric mean, right? So this whole thing power 1 by 6, the 6th root of this, right? So we know that x plus y plus z equals to 3, right? 3 by 6 equals to half. We know that half is greater than equal to this. If I take the power 6, so I can write this as power 6 is equal to x into y square by 4 into z cube by 27. Right? Now, what do we want? What is the maximum possible value? Right? So the maximum possible value of this will be you just simplify this, right? If you simplify this, you'll get x into y square into z cube is less than equal to, so if you simplify this, you'll get 27 by 16. You'll get 27 by 16. So if this is less than equal to this, what is the maximum value that it can achieve? The maximum value it can achieve is 27 by 16. Again, this problem was tricky for two reasons for me personally. It took me a while to figure out that I had to break it into this form and apply arithmetic mean and geometric mean. But one thing that I realized, that I have to apply arithmetic mean and geometric mean very quickly, because this looks like a sum and this looks like a product. Whenever you have to compare these types of things, it makes logical sense to use arithmetic mean and geometric mean. But I couldn't find out, it took me a while to actually decompose y into y plus 2 and y plus 2, and decompose z into z plus 3 plus z plus 3z. So this part was a tricky part. This part I could almost come up with it almost instantaneously the moment I saw a product term here and a summation term here, right? So this was a tricky part. Again, this is one of the harder problems without doubt. Okay, so let's go to the next question now. Okay, so let's see this question. So it says, what if f of x is this, then the range of f of x, right? What all values can f of x take? You can easily discuss about the range of values that f of x can take if you can find the maximum value and the minimum value of this function, right? Right? If you know the maximum value and minimum value of this function, you can tell what all values will this function take, or the range of f of x, right? So very simple. You just differentiate it, right? So if you differentiate this numerator, so if you differentiate this, right? Again, you differentiate it and make it equals to 0. So if I differentiate it, okay, this is going to be tricky. So this is like a ratio term. Okay, let's try to differentiate it, right? So if I differentiate it, what I'll get here is this, okay? I'll get 2 plus cos of x, right? 2 plus cos of x into cube root of cos of x. Okay, actually let's write it down. Actually, let's write it down much more simply, right? So again, I'm doing some more hack here, right? So let's actually write it down as cube root of cos of x on the numerator minus cube root of sine of x into minus sine of x, right? So this is what I get, right? So anyway, I'll write the whole expression here. 2 plus cos of x is what I get by, right, 2 plus cos of x squared. Right? This is what I get. Now I'll just equate this to 0, right? So if I equate this to 0, again, this is one of the easier ways to solve it, right? So if I equate this to 0, then what do I get? I get 2 into cube root of cos x plus, root 3, sorry, not cube root, root 3 of cos squared x plus square root of 3 sine squared x equals to 0. Right? So this is what I get, because this is equal to 0, right? This whole thing will be equal to 0. Now, what is this? If I simplify this, again, we have to use some trigonometric identities here. So this I'll get it as 2 cos x plus 1 equals to 0, which means x is going to be equal to 2 pi by 3, right? Because I have cos x equals to minus 1 by 2 or minus 2 pi by 3. These are the two places where I'll have it, right? And if I take x equals to 2 pi by 3, what will this expression be equivalent to? This expression at x equals to 2 pi by 3 will be equal to plus 1. And at minus 2 pi by 3, this expression will be equal to, sorry, this expression will be plus 1 and minus 1. Yes, right? So the whole interval is minus 1 and plus 1. Okay, that's what it will be, right? Again, this is slightly tricky problem to solve, but it's very much doable, to be honest, right? So yeah, so that's what it is. So we've solved 15 problems. There are some more problems left, but just in the interest of time, because it's also a Sunday evening for everyone, there are some more problems left, but we've given detailed solutions to all of these problems, right? So we typically try to solve 15 problems as well as we can. And to be honest, I'm also getting exhausted solving problems and doing multiple live sessions from morning. So just in the interest of time and to avoid me doing any silly mistakes, we'll stop at the 15th problem. And let me just go back. Sorry. So sorry. Yeah. So we'll stop here and let's close out. So there are 5 more problems. And again, for each of these problems, we have given detailed solutions. We have given detailed solutions to each of these problems. Once you submit the test, you get detailed solutions for all of these problems, right? So please go through them. Again, with calculus almost ending, just give us feedback on calculus content also. If you think there is something that we should add, do let us know. or if you want us to cover more concepts, we'll certainly revisit again. See, somebody was asking that he had exams. One of our students was asking a while ago that he had exams and he couldn't cope with the content. That's perfectly okay. If you couldn't cope with the content, that's okay. Whatever subjects you could not cover thoroughly, just skip them for now. Follow us now, right? Since exams are over, let's quicken up, let's follow. And whatever subjects you've missed out, for example, if you've missed out linear algebra and calculus, right, we'll anyway cover these concepts after all the subjects are done once again. For those of you who want to revise, and also for those of you who want to catch up with this. So you can always finish these concepts later on. It's best for you if you follow with us so that you have a disciplined timetable on completion, right? With that, from tomorrow onwards, let's start discrete mathematics, especially the concept called as algebraic structures. So we'll start with things like sets, relations, right? We'll start with sets, relations, functions, groups, all of these concepts, right? Very interesting set of concepts in discrete mathematics. And we'll try to finish them in 6 days. Again, my team will anyway put out some detailed topic-wise split for the next 6 days. So we're trying to finish all of these concepts in the next 6 days. So that once we finish this, we can go to graphs, right? We can go to graph theory in again discrete mathematics. So if you finish graph theory, is there any other? Oh, then we have probability. I forgot. We have probability also, the next concept, right? So if you can finish this in 6 days, we'll go through probability again, maybe 5 days or so. We'll go through probability in 5 days or maybe 6 days. Again, graph theory in 5 to 6 days. Then we'll be mostly done with, I think, everything. If there is something missing anyway, we have a detailed plan for it, right? So let's finish off all of engineering mathematics and discrete mathematics. Once we are done with it, then we'll move to other core subjects. I'm also looking forward for other core subjects, but please don't misinterpret that discrete maths is not a core subject. It's a very, very important subject in computer science, right? I think after C, data structures, algorithms, right, after this subject, I think discrete maths or engineering mathematics, the whole mathematics, I think this is the most important subject in terms of scoring. Then obviously you have the whole of maths, both discrete and engineering. Obviously you have your English plus aptitude also, which is very scoring. So we're trying to come in the order in which they are most scoring, right? Again, different people who are joining in different batches will anyway cover C, data structures, algorithms again for you. And people who are joining now, please try to follow the schedule that we have now so that we can all be on the same page and practice together and try to get the best results.